Alright, let's talk about simplifying surds. In the last lesson we learnt about surds. They're irrational numbers written in a square root form. I've got something in a square root form here, but I don't know that this is a surd because this may or may not be a rational or an irrational number. So I can take root 32 and I'm going to simplify it. And here is my rule. The square root of x and y, so two factors, x and y, I can split them apart and write it as the square root of x times the square root of y. So I'm going to look for some factors of 32. So I could write 32 as 32 times 1, or I could write it as 16 times 2, or I could write it as 4 times 8. The thing I'm looking for here is I'm looking for, before I do that, my rule here says I can split them apart. So I could write that as now the square root of 32 times the square root of 1. I could write this as the square root of 16 times root 2, or I could write this as root 4 times root 8. Okay. What I'm looking for here is I'm looking for square factors. In other words, numbers here that are square numbers, because I can undo that square easily. Because I know the square root of 16, for example, is 4. I know that the square root of 4 is 2. So I could replace those with integers, whole numbers. But I'm looking for the largest one. I always want to use the largest square factor. So I can take my example now and I can see that this is the largest square factor. So I'm going to take my square root of 32. I'm going to separate it as square root of 16 times the square root of 2. I can see that this is a square number, so I can undo the square root. So the square root of 16 equals 4. And that's my answer, 4 root 2. So I've simplified root 32 down to 4 root 2. And root 2 is a surd. I can't simplify that anymore. If I was to take 4 root 2 and put it into my calculator, I would get a decimal that is infinite and non-recurring, which was the definition we used in the previous video for a irrational number. Let's take one more example just to practice what we just learned. Simplify 4 root 27. So this means 4 times root 27. I'm looking for the factors of 27 that I can separate out, one of which I want to be a square number, and I can see that this one here is a square number. So I can rewrite that as 4 times root 9 times root 3. The square root of 9 is 3, and now I can just tidy things up. 4 times 3 is 12, so this bit becomes 12. And just like in algebra, if we've got a number in front of or multiplied with a square root, we can take out the multiplication sign. So I'm going to write that as 12 root 3. So 4 root 27 simplifies down to 12 root 3. That's how we simplify surds when we're looking at multiplication.